So, good afternoon everyone. Today we will see numerical integration. In last class, we have derived these different rules by using Newton's codes formula, okay, quadratic formula. So, what we are doing? So, we are finding the value of integration from a to b f of x. Okay. So we are finding the value of integration f of x dx from a to b, and let's suppose this is the curve, this is a and this is b, and this is f of x or equal to y, and this is x. So we are finding the area under curve between f of x and x. Okay. So we have derived the Newton's codes quadratic formula. Okay, and from there we have putting n is equal to 1, we got this trapezoidal rule. Okay, so this is formula of trapezoidal rule, and then putting n is equal to 2 in this Newton codes quadratic formula, we got this Simpson's 1/3 rule, and then putting n is equal to 3, we got this Simpson's 3/8 rule. Okay, so these are three different rules to find this integration a to b f of x dx. There is two more rules, Bull's rule and Gödel rule. So I will tell it later. Okay, so here. So this is integration from x naught to x naught plus h. So we have taken this as x naught, and this is x naught plus n h, okay, which is xn. Okay, so we are integrating from x naught to x naught plus n h, and where to apply this formula. Okay, so we have to check where you should apply these formulas. Okay, so first. The Newton's trapezoidal rule is applicable for any value of n. Okay, so it is applicable for any value of sub-interval n. Okay. And this Simpson rule, we got this rule when we substituted n is equal to 2. Okay, so this is applicable for n is equal to multiple of 2. Okay. When multiple of, okay, so we should have the applicable for n is equal to multiple of 2. So the multiple should be even. Okay, so the subintervals we are taking, it should be even. So when subintervals are even, you go with Simpson's 1/3 rule. Okay. And for this, it should be multiple of 3. Multiple of 3. Okay, so n should be multiple of 3. Then only you can apply this Simpson 3/8 rule. Okay, so trapezoidal rule can be applicable for any value of n. It may be even, odd, or multiple of 3. So there is no obligation for that. So you can use for any value of n. And Simpson's 1/3 rule is applicable when n is multiple of 2. When n is even, okay, then only you can apply the Simpson's one-third rule. And Simpson's 3/8 rule is applicable when n is multiple of 3. Okay, it should be 3, 6, 9, 12, and so on. Okay, so this is divided into multiple of 3. Okay, so here number of sub intervals, that is number of sub interval taken as multiple of 3. We should take care of this. So when the number of sub interval, that n is multiple of 3. Okay, so so this is so these are the formulas for trapezoidal rule, Simpson one-third rule, and Simpson 3/8 rule. Okay, so it is h by 2. It is small interval. Y naught plus last value of y, y1 plus y2 plus y3, and rest values. Okay, and here when we use Simpson's one-third, it is 1/3. When Simpson's 3/8 rule is used, it is 3h/8. Okay, so here what we write, the even values 2 plus the even values plus 4 the remaining values. Okay, you can remember like this. And when we are using 3/8, so here 2 times, here we have taken even values, here multiple of 3 will be there, and then here it is thrice of the remaining terms. Okay, so how to remember this? So Simpson one-third h by 3, Simpson 3/8, 3h/8. Okay, and then 2 plus even values of y. Okay, and here twice of multiple term of y. Okay, and here remaining terms of y. Okay, so in this way you can remember the formula. Next, third or fourth, we will see Liddell formula. Okay, so all these rules has been derived from this Newton's 4 quadratic formula. Okay, so these all are approximate value. Okay, so next, fourth is Liddell's rule. So x naught plus n h f of x dx is equal to 3/8 by 10 y naught plus 5 y1 plus y2 plus 6 y3 plus y4 plus 5 y5 plus 2 y6. Okay, and this formula is applicable the number of sub intervals should be taken as. So we get this formula when we had put n is equal to 6, so it should be multiple of 6. So n should be multiple of 6. Okay, so why we are taking this as multiple of 6, n should be equal to 6, because we got this formula putting n is equal to 6. So this will be applicable for multiple of 6. So this formula is applicable when n is multiple of 6. Okay, so trapezoidal rule, value of n can be anything, it can be odd, even. For Simpson one-third rule, value of n must be even, and for Simpson's 3/8 rule, the value of n must be multiple of 3, and for Liddell's rule, value of n must be equal to 6. Okay, so this is the criteria for application of these rules for the various problem. Okay, so you should remember this. So we will solve some problem based on these rules. So first question is, use trapezoidal tool to estimate the integral 0 to 2 e x square taking 10 e plus. Okay, so here it is given you have to take the number of intervals n is equal to 10. Okay, so it is clear. So you have to find the integration of this value 0 to 2 e to the power x square. Okay, so first we have to take y. So we need y value of y. So let y is equal to e to the power x square. Okay, so first thing you have to so you have to assume e to the power x square as y. Okay, and value of h will be h will be equal to it has in 10. So it is b minus a divided by n. Okay. So it is a and it is b. So upper limit minus lower limit, that is 2 minus 0, and number of intervals is 10. Okay. So this will be equal to 0.2. Okay. So first step you have to find the value of f of x, that it is y. It is e to the power x square. So this is assumed as y is equal to e to the power x square, and then you have to find the value of h. In formula you need h, so h is equal to b minus a, that is upper limit minus lower limit divided the number of intervals. So it is given in the question, number of interval is 10. So upper limit is 2, lower limit is 0, so 2 minus 0 by 10, so it is 0.2. Okay, and n is given as 10. So we have to apply this trapezoidal rule. So from trapezoidal rule, integration 0 to 2 e to the power x square. Okay. So we have to write the formula. Okay. This is h upon 2 h upon 2, first term and last term will be by 10 plus 2 into y1 plus y2 plus y3 plus y4 plus y5 plus y6 y7 plus y8 plus y9. Okay. So you require various values of y. Okay. So y0, y1, y2, y3, so up to y10. Okay. And values of y is not given, but we have assumed that y is equal to e to the power x square. Okay. So now we will find the values of y. Okay. So in order to find this integration. Okay. So first thing you have to remember this formula. Okay. So this is trapezoidal rule. So here you require the values of y0, y1, y2 up to yn. Okay, so again we have to prepare a table for the various values of x. So first values of x. So it is integration from 0 to 2, and intervals are subintervals are 0.2. So we start with 0, then 0.2, then 0.4, 0.6, 0.8, 1.0, 1.4, 1.6, 1.8, and 1.0. So in this way, we have to divide the values of x. Okay, then corresponding value of y. Okay. So what we have, the value of y is equal to e to the power x square. Okay. So y naught will be equal to e to the power 0. Okay. Then y1 will be equal to x is equal to 0. X is equal to 0.2. So e to the power 0.2 whole square. Then x is equal to 0.4. Y2 is equal to e to the power 0.4 square. Then x is equal to 0.6. Y3 is equal to e to the power 0.4 cube. When x is equal to 0.8, y4 is equal to e to the power 0.4, 0.6 square, 0.8 square. Then x is equal to 1, y5 is equal to e to the power. Okay. So first we have to find the values of y. There is values of y corresponding to the x. Okay. So this is equal to this will be 1. This is 1.048. This is 1.1735. And then 1.433. Then 1.8964. This is 2.17. Okay. So what we have done? So here we have to find the values of this is x0, x1, x2, x3, x4, and so on. We have to find the corresponding value of y. Okay. So this is when x is equal to 0. So this is e to the power 0. Then 0.2, 0.4, 0.6, 0.8, 1, 1.4. You have to substitute the values of x in this equation. Okay. So correspondingly, the values of y are 1, 1.048, then 1.1735, then 1.433, then it is 1.8964, 2.178. Okay. So this is y0, y1, y2, y3, y4, y5. Similarly, you can find this. 1, 2, 4, 6. Okay, so again we have to substitute the values. So when x is equal to 1.2, y6 is equal to e to the power 1.2 whole square, and x is equal to 1.4, y7 is equal to e to the power 1.4 whole square, x is equal to 1.6, y8 is equal to 1.4, 1.6 whole square, x is equal to 1.8, y9 e to the power 1.8 whole square, and x is equal to 2, y10 is equal to e to the power 2 square. Okay. So you will get y6 is 4.206. This is 7.9. So this is using exponential. So 12.9358. This is 25.5337. Substitute these values here. So 4.4206, 7.0933, 12.9358, 25.37, and 54.59. So you have to prepare this table by using this equation. Okay. So this is x0, x1, x2, x3, x4, x5, s6, s7, s8, 9. So these are values of s. These are values of okay, and now we'll substitute these values of y1, y0, y1, y2 up to y10 in the given equation. Okay. What we have, this is, so I will write this formula again. This is from 0 to 2, e to the power x square dx is equal to h upon 2, first term and last term, by 2, rest of the values, y3 plus y2, y3, y4, y5, y6, y7, y8 plus 1. Okay, so this is by trapezoidal rule. So value of h is 0.2. So this is 0.2 by 2, and y0 is 1, and y10 is 54.5918, 54.5981 plus y is rest of the values 1.0480 plus 1.1735 plus 1.4333, 1.8964 plus 2.1784 plus 4.2206, 7.0993 plus 12.9353 plus 25.3. Okay. So I'm solving this. Value is 170.06. So this is approximate value. Okay. So this is a very simple method to finding integration of any expression. So we have to find the value of integration 0 to 2 e to the power x square dx. Okay, using trapezoidal rule. Okay, so you have to remember this formula. So h upon 2 y0 plus y10 plus 2, y1, y2, y3 and up to y9. Okay. So in the question it is not given, values of y is not given. Okay. So only this function is given, x square e to power x square. So first you have to take it as y and then substitute the values of x, okay, in this equation, and you will get corresponding values of y. Okay. And in question it is given n is equal to 10. Okay. So it is clear, you have to take n is equal to 10, and how to take h is equal to b minus a upon n, where b is upper limit and a is lower limit divided by number of intervals. So this is 2 minus 0 by 10 is equal to 0.2. So this is how you have to calculate the value of h. Okay. Once you got all the values of y, substitute in this equation. Okay. So you can find the value of this integration. Okay. So and this is approximate value. Okay. So we are using numerical integration, so we will get this approximate value. Okay. So now we will move to some applications of this method. Okay. So I think this is clear. Any doubt in this question? So second question. The velocity v in kilometer per minute of a moped. So a moped is moving with this velocity, which starts from rest, initial value of velocity is 0. Okay. So which start from rest is given at fixed intervals. Of time. Which is in minutes. As follows. So here table is given, no need to prepare a table. So T is given and B is given. T is in minutes and it is in kilometer per minute. Okay. This is 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. Okay. So moped is moving from rest and up to 20 minutes. Okay. So corresponding values of voltage is given. So at 2 minutes it is 10 km per minute, is 18, so it is accelerating up to 32. Okay, so this is the maximum speed, then it is decelerating and then becomes 0 at 20 minutes. Okay, so find this speed. The distance covered, approximate distance covered. Yes, sir. In 20 minutes. Okay, so you have to find the distance covered by this moped, which is moving with this velocity, okay, at different intervals. So at the starting v is equal to 0. So it starts from rest. That means it is starting at t is equal to 0. The velocity of this moped is 0, and then it is exerting. Then 10, 12, 18, 25 is exerted up to 32 kilometer per minute. Okay, and it is in, and then there is a deceleration. Okay, so you have to find distance covered. Okay, by using this numerical integration. So you have to find the distance covered approximately. Okay, so this will give approximate value. So we know that distance covered as can be calculated by integration of velocity with respect to time. Okay, so and time is from rest to 20 seconds, 20 minutes. Okay, so this will be the equation. So distance covered as is equal to integration of velocity, so this velocity with respect to time, and it is starting from rest, that t is equal to 0, and it is traveling up to 20 minutes. So this will be equation from 0 to 20 seconds. Okay, so this is how we will calculate the distance covered. Okay. So no need to prepare this table. It is already given in this problem. Okay. So which rule we should apply here? Anyone? So number of intervals is even. Okay. It is up to 20. So anyone can tell? So there is trapezoidal rule, there is Simpson rule, Simpson 1/3, 1/8, and Gödel's method. Okay, very good. Simpson's 1/3, because n is even. So we will apply Simpson's 1/3. Okay, so integration s is equal to integration from 0 to 20. We x upon 3 plus first value y0 plus y10. So here no need to write y, so it is v is given. Okay, so this will be v0 plus v10. Okay, so here this initial value is also given. Okay, so this will be v and v, and this is 0 and 0. Okay, so this is v0, v1, v2, v3, v4, v5, v6, v7, v8, v9, and similarly t0, t1, t2, t3, t4 up to t10. Okay, so this is v0 plus v10 plus 2 times the even terms, v2 plus v4 plus v6 plus v8. v10 is used here. Okay, and then 4 times remaining times, the odd times, v1, v3, v5, V7 and V8. So okay, this is how you have to remember this formula. Okay, so first write h by 3. This is 1/3 rule, h by 3. Okay, then first term and last term. So first term is V0 and last term is V10. Okay, then twice the even terms V2, V4, V6 and V8 plus 4 times the rest term, that is odd terms of V. Okay, and it is quite simple. You have to substitute the values of velocities V0, V2, V3 up to V10. Okay. So before that, we have to find the value of h. Okay. So here we need value of h. Okay. So how to calculate this value of h? Anyone can tell what will be the value of h? How to calculate this value of h? Anyone? So this is value of h is upper limit, that is b, minus lower limit of integration divided by number of intervals n. Okay. So upper limit is 20, this is b and this is a. So 20 minus 0 divided by number of intervals is 10. So this is 10, so this will be 2. Okay, Tushar, very good. So this is h is upper limit minus lower limit divided by h. So upper limit is 20 and lower limit is 0. So this is 10. So this will be equal to 2. Okay. So then substitute the values. So distance covered S will be equal to from 0 to 20 ddt will be equal to h is 2 upon 3. Then V0 plus V10. V0 is 0 and V10 is 0. Okay, so this is initial value of velocity and then value of velocity is 0 plus 4 times our term. This is V1 is 10. Then V3 is 25 plus 32. V5 is 32. 11 plus 2. V7 is 11 and 2 is V9. Okay. Plus twice the even terms of velocity. This is 10 and 18 and 29 plus 18 plus 29. So V2 and V4, then V6, 20 and 5 plus 20 plus 5. Okay. So this is very simple. Okay. So solve this, you will get 309 on 33 per minute. Okay. So first, you should know which formula has to be applied here, and then you have to find the value of h and values of v is given here. Okay. And one thing you should remember here, in table you should incorporate this value of T naught and V naught. Okay. So the simple mistake we take do here. So we take this as V naught. Sorry, T naught and V naught. Okay. So you should consider this value of T naught and V naught also. Okay. So this is the application of this Simpson rule. You can find the distance traveled. Okay. So we will take another question, last question of the day. So here we have to find the value of volume. Okay. So these are application of these rules. Okay. Practical examples of these rules. So third question is, so it is important one, now in question details. So a solid of evolution is formed by rotating about the x-axis the area between the x-axis the lines x is equal to 0 and x is equal to 1 lines and occur through the points with the following coordinates. Value of x and y is given. So x is between 0 and 1. Okay. 0, value of y is 1. 1.25 is 0.9896. 0.5, value of y is 0.9589. 0.75, 0.9089. 1.00, 0.84. Okay. So estimate the volume. So you have to find the volume of the solid formed. So we have to find the volume of the solid formed by these coordinates by using Simpson's rule. So in question it is given you have to apply Simpson's rule. Okay. So by Simpson's rule it is understood. Okay, fine. So this is S is equal to integration. Now you have to find the volume of the solid formed by Simpson's rules. Okay, so by Simpson's rule, it is clear we have to apply Simpson's 1/3 rule. So Simpson's 1/3 rule is also known as simply Simpson's rule. Okay, so we have to find volume of the solid generated by using these coordinates. So value of x is extending from 0 to 1 and we got different values of y. Okay. So first we have to find the value of h. Okay. So h can be calculated from upper limit to lower limit divided by number of intervals. Okay, and it is clear it is 0.25, 0.5, 0.75 and 1. So no need to calculate. It is quite obvious from the table. Value of h will be 0.25. Okay, and you need to find values of y. So y naught is equal to 1. Y1 is 0.9896. Y2 is equal to 0.9589. Y3 is equal to 0.9089 and Y4 is equal to 0.8415. So this is x0, x1, x2, x3, x4. So corresponding value of y, y0, y1, y2, y3 and y4. Okay. So required volume of the solid generated. So volume V will be equal to integration pi y square into dx, and x is extending from 0 to 1. Okay. So this will be the formula for finding the volume. Okay. So this is extending from 0 to 1, and this is area into dx. Okay. So this is pi r square. Okay. So this will be pi y square. Okay. Here the radius will be y square into dx. Okay. So this will be equal to pi. So here it is y square. Okay. So we are applying Simpson's 1/3 rule. So y1, so y0 plus last term is y4. Okay. Plus 4 times remaining and plus 2 times even terms. Okay. So even terms is this is y0, y1, y2, y3 and y4. So here only we get one value of even term, this is y2, and then remaining term y1 plus y3. Okay, but it is here y square. Okay, so this will be y square, y2 power 4 square, y1 square, y3 square and y2 square. Okay, so you have to take this as note. So when this is y square, so this will reflect in this side also. So in this formula, so when there is only y dx, so it is y0 plus y4 plus y1 plus y3 plus twice of y2. But this is y square, so this will be y0 square, y5, y4 square plus 4y1 square plus y3 square plus 2y2 square. Okay, so all the formula, all the values of y is given. So simply substitute here. So volume will be equal to pi h is 0.25 divided by 3 into y0 is 1 plus y4 is 0.8415 whole square plus 4 times y1 square, y1 is 0.9896 square plus y3 is 0.9089 square plus twice into 0.9589. Okay. फाइव कहाँ है ये यहाँ से y0 से स्टार्ट करो ना y0 y1 y2 y3 and y4 simple. Okay. So volume will come as 2.819 into Okay. So this is the question. Value of x is given, value of y is given. You have to find the volume. You can find the value of area also. You can find value of velocity. Okay. So here h is given. It is 0.25 minus 0. So this will be 0.25. So you have to apply Simpson's rule. So this is Simpson's rule, and here it is pi into y square into dx. Okay. So this will be y naught square plus y4 square plus y1 square plus y3 square y2 square. Substitute these values and find the volume. Okay. So this will be the volume. Okay. So any doubt in this question? Okay then. Thank you, class.